Hey guys, I'm back, and so if you notice the videos have been tapering off a little bit lately. I'm not losing interest in these videos or anything, although admittedly I am slightly, because nobody's watching them. And when nobody watches your YouTube videos, it gets very frustrating very quickly, and you want to stop. So for those loyal following me, thank you so much. Yeah, and if you want to request an episode on something, by all means, please do. But anyway, this is just something I figured out recently. If you go to this website right here, it will be in the description of this YouTube video. It tells you the current state of the Large Hadron Collider, which is in Geneva. It's looking for the Higgs boson. And actually, they just got a gluon plasma in it. Anyway, that's for another video that I would probably do. But you can see the current state right here at this page, and you can switch pages, but I'm going to be going over this main page right here and how to read it. So right here under this E, you can, I guess I can just refresh it and it'll go away. Sorry. Right here, this is how many, the energy it's running at, and this is per beam, so each beam now has 3,500 giga-electron volts on average, which is 3.5 tera-electron volts. Right here you can see this is just the energy again. These are the luminosities of the beams, and you can see here we have a graph of luminosity and a graph of beam energy over time. So as you can see, a couple hours ago they injected the beam into the LHC and the beam has remained stable. Right here they have the luminosity that the different detectors are reading. So you can see LHCb is reading about 300-ish. CMS is up to 1075 going down. Atlas is all over the place, and Alice is just all the way sitting there at the bottom because they're not running. They're running, as you can see right here, tells you whether they're in ion physics or proton physics. Ion physics would be accelerating the lead ions, protons would be doing protons, obviously. So right here we have some simple flags. The ones you really want to worry about if you're looking at it are stable beams. Okay, this is for beam 1 and beam 2. Stable means if they have to be stable to collide. So you have to make sure they're stable. And then right here, the status of beam 1 is enabled and beam 2 is enabled, meaning enabled means they can collide. And then right here is something that they will write, the people in the control room will write based on what's happening. So if there's collisions, I suppose they'll write collisions. Right now they're writing optimization on request, stable beams, and as you can see here, it says stable beams and stable beams. So right now the beams are stable, but they aren't colliding it. So that is they're just sort of, the beams are circulating at 3,500 electron volts. So this is the current status of the LHC. Now if we go to this drop-down menu here, if you want to learn more about how to read it, you can just click that question mark. Anyway, we want to get into a bit more specifics. You see, we have all of these things, and so right now we're at page 1. If we go into operation, you can see that it will give us a whole bunch of different stuff, as in we have the energy over the last 24 hours. So you can see they ramp it up, down, and down, and the energy in black, and right now they're at 3,500 giga-electron volts, or 3.5 TeV. So this is their current energy. And right here you can see that the status of the main detectors and Totem, which is one of the smaller other detectors, is on standby. But Atlas is on physics, and the rest of them are on physics. You can still see the energy and the luminosity for the two beams. And we have the background. We have some graphs here. We can also get into dashboard. This is a really general thing, but they have lots of graphs for almost everything: luminosity, bunch intensities, other stuff, feedback, the beam sizes. Right here we have the tune. You can see again the energies, the times, the proton bunches, the injection schemes, bunch of great stuff. If we look at configuration, we can see how it's configured to work. Accelerator mode, proton physics, beam mode is now at stable beams. You can see the beam separation in Atlas is 0, meaning they're colliding. Alice is these, so the beams are separated, meaning they're not colliding. So for Alice right here, Atlas, sorry, you can see we get luminosity and lots of other stuff. So I'm not really sure what half of this stuff does, but it doesn't really matter. You can do cryogenics. I guess we can get into something more specific, like the proton synchrotron booster. Let's get into that, and then we can see how it's what's actually happening. Oh, we just got stuff added, and it does update in real time, I assume. Let me see something interesting. The super proton. Oh, oops, that's not what I meant to do. But for the super proton synchrotron, right here you can see this is their magnetic fields. This is a great example right here of how to read this graph. This is their the white is the magnetic field. So this is their ramp up here to increase the proton's energy to 450 gigaelectron volts, which is their energy after they leave the superproton synchrotron. And then this is the top here. This is when they're being released into the Large Hadron Collider main ring. And then this ramp down is when they are actually, everything is left the superproton synchrotron. And then it's just ramping down the magnets. And then you can see multiple ramp up and ramps downs. Right here you can see this bar that moves along, and these change. So it tells you what happens is right there it's injected and they've ramped it down. Again, at the bottom you see that it's injected, they've ramped it down. Wait for it to change again, and right here at the top is where they inject it. And you can see that right here you can see the comments is that they're having injection troubles. So I just wanted to inform you guys of the way that you can actually get data on the Large Hadron Collider live. There's this address, but its sort of main page is LHC page 1. And as you can see, stable beams, optimization on request, they're all ready to collide. So, as of the moment right now. But anyway, that is on the LHC, and this will be in the description right here. But for those of you who don't want to look at the description, it's op/webtools.web.cern.ch/op-webtools/visitors/op/.php USR equals LHC1, LHC being capitalized. Okay? Thank you for watching. Oh, and for the contest, this is microphone number, let me check, 3. So, watch out for that contest coming up, microphone number 3, this one. So, thanks for watching, comment, rate, subscribe. Hope you enjoyed the video. Bye.